So today I'm joined by Saša Jurić, who is a low-key legend of Elixir community. He is a self-proclaimed Erlangalist, and wrote a book about that subject of using Elixir to achieve things, to make computers do things. And the book is really cool. And right now he is an independent consultant, as far as I understand, right? And today we're going to talk about Elixir from the standpoint of, for me, it will be like coming back to it after a big pause because I basically stopped really following what is happening in Elixir closely around year 2015. But Saša obviously was and still is following quite some news, speaking at the conferences and contributing maybe some libraries and things to the ecosystem and whatnot. We're just waiting right now for people to gather. So Saša, if you have something to add to my exprompt introduction, you can do that.
Well, thank you, Jonn, and hi everyone who is already here present. So I guess I'm gonna use this opportunity to introduce Jonn, who is currently working for Serokell, right? Or you're basically one of the founders. Is that correct?
Yes.
Yeah. And Jonn is one of the early adopters of Elixir, as far as I remember. I mean, we met way back, like something like 2013, if I remember correctly.
13, I think.
Yeah, so it was still pre 1.0. We kind of met at we were together or we were separately, but on the same event, Erlang event, and then later Jonn was living here for actually some time here in my home city, and we had a lot of these informal chats about Elixir and IT in general, right?
Yeah. So some are traditional, but obviously due to a number of reasons we can't follow our tradition today.
We're going to resume that tradition. Yeah.
Oh, for sure. Yeah. But I don't think YouTube or Twitch even would allow us to do what Croatian pubs allow us to do. But
but you're going to come back, right?
Of course. It's like you can never really quit Croatia, I think. But I think that we can start. And for people who are new to Elixir, which there are quite some, and especially among like developers in general, but also among Haskell developers, let's very briefly talk about what is Elixir and why should people care about it? Like what is the differentiator between Elixir and other languages that are on the market?
Mm-hmm. So Elixir is a programming language. It's a programming language that targets Erlang virtual machine or compiles down to the same bytecode as the Erlang programming language. There are a couple of other similar languages which we'll maybe mention during this chat, such as Gleam and others. So you can, in theory, of course, write any kind of programs with Elixir. But really where they shine, where Elixir and these other languages shine, are what they call software systems, right? And so what this means is like any kind of a backend, any kind of a web server, databases, for example, would be good examples, message queues. Any sort of a piece of software that once you start for the first time in production, you expect it to run continuously for a long amount of time, like, a couple of years or decades. And during its lifetime, this program is going to do a bunch of different things. A bunch of different independent tasks are going to be executed. Like in a typical web server, you're serving requests, for example. This is the most obvious example, but other than just serving requests, you're doing other kind of things like running background jobs, some kind of background processing, maybe pulling some data off of the external feed like Twitter or something like that, maybe you're doing some periodical cleanups and those kind of things, managing in-memory state or archiving stuff. There's a lot of things happening in any sort of a system. And what's really special about this is that these things are mostly mutually either independent or very loosely dependent. Therefore, the program operates in shade of gray of success. This is a very important point because like when you think about a normal standard program that we learn, you write hello world. Okay, this is maybe too simple. But when you write, say, a compiler, compiler either succeeds or fails. There is nothing in between. And it can, of course, report compilation errors, but this is also a success from the standpoint of the compiler. It detected some errors and reported this is wrong and this is wrong. But for a software system, you actually have these shades of gray of success. So like if there are thousands of us accessing some server, and if it works for 999 of us, it's still mostly successful system. Of course, it's not perfect, but still provides a lot of the service. So this is the core idea, that you basically have this continuous scale between doesn't work at all, which of course you don't want to have, and works perfectly for everyone all the time, which really, even in a remotely, complex system, is hard to achieve. So essentially, what everyone will tell you, that any sort of a system is going to have some failures. But what you want to do is capitalize on the fact that it's not a binary, succeeds or fails, and you therefore want to increase or improve the chances of most things still working, right? So this is the particularity of software systems, and as it just so happens, Elixir and fundamentally Erlang actually is designed to attack those kind of problems in a very systematical and predictable fashion. So it basically has like some building blocks, pretty simple building blocks, but very powerful, very attuned to this particular kind of challenge, to allow us to build the system in a way that we can separate failures of different activities, such that most of the system is working when something goes wrong.
Right, and for Haskell developers, I'll let Saša to talk a little bit more about the differences. But in my personal experience, this is a drastic difference between how Haskell, for example, approaches the notion of correctness of system versus how Elixir or Erlang takes this approach. Because if you think about Haskell, okay, it kind of emphasizes that everything should be correct, and that means that only states that the system has to be in should be correct. And when there is an error, it has to be explicitly handled. But sadly, and it comes from basically what Saša said, from the fact that we are working with complex systems, normally the errors that we're facing are emergent properties rather than some deterministic bugs that we wrote by negligence. And this is why this kind of model where and since it's emergent properties, these errors are kind of implicit within how you encode your Haskell programs. So you have to be very rigorous and actually write very defensively if you want to implement like a system that is very complex and that will run for a long time in Haskell. So this is for me like the biggest practical difference within within the framework that Saša proposed. But if you can name like any theoretical maybe differences between Haskell and Elixir for our Haskell listeners, which there are plenty, please do.
No, I think that you're the authority on that one, because you worked extensively with both languages, right? So I'm going to take your word, but I just wanted to say something to add to this. I think that you really nailed it perfectly, because the interesting thing about Elixir and Erlang and those languages on BEAM, on the Erlang virtual machine, right, is that you actually don't have to try too hard to build a resilient system. It doesn't really happen by magic, but it's not a lot of work. Essentially, defensive coding is sort of an anti-pattern when you write in Elixir. You actually pretty much want to have like fast failures. This is what is known as let it crash, but it's probably a bad naming. It confuses people. It pretty much means fail fast. Fail as soon as something is off. You want to fail. But the whole idea is because you take this Erlang philosophy of splitting this huge system into a bunch of smaller independent programs. So this comes through lightweight concurrency, which we should probably explore a bit more. But when you do that, then something fails, but it's not too big to fail. You essentially lose a small piece, and everything else is working. And I remember from my first production that I did so many things wrong. I really didn't know what I was doing. You have like this frequent meme where the dog is typing on the keyboard and which says, I don't know what I'm doing. That's like basically me in my first Erlang production. And, I was like super surprised when I would, come to the work and take a look at logs and see a bunch of exceptions, but the system is still working and nobody reported anything, and I remember, like calling the support people, like, are you sure there were no problems? Because, I see a lot of stuff in logs, but, so I'm confused. And I remember actually, figuring out that, okay, I need to really understand how this is working. Why is my system working? It's supposed to be dead, So that's when you appreciate how much like a tool can do for you.
Yeah. So you mentioned concurrency. Maybe we should talk about that. And how does actually Erlang virtual machine achieve this?
Right. I mean, it's a pretty simple idea, but I don't want to go into details too much. But just so people can, who are new to these languages, who can understand, the essential idea is like pretty simple. You basically have this massive lightweight concurrency where you can split the execution of the program into a bunch of independent sub-programs, so to speak, which we call processes. Right. And so the process is not an OS process, but it has similar semantics because it's an independent program that runs in logical isolation from other processes. It still runs in the same OS process, but otherwise it's completely isolated. Like you have two processes, each one has its own stack and heap, its own memory space. And most notably, when a single process crashes due to an unhandled exception, then nothing else is taken down by default. So everything else is still running. So the crash is not an abrupt event, like saying Go, where you have these Go routines, and if you have an undeferred panic in Go, then basically the entire program goes down. This is the complete opposite in BEAM. And at the same time, this crash is not a silent event, right? So any other process in the system, any other program in the system can be notified about the crash of other things. And so you can build this fault tolerance pattern. This is what Joe Armstrong, the creator of Erlang, said. You basically, if you want fault tolerance, you always need more than one, right? So you need someone who does the job and someone who detects when the worker is not doing the job anymore. Maybe, it's stuck, maybe it went down or whatever. And then this other thing, this other process can actually do something about it, right? And so that's essentially the idea. And of course, it's worth mentioning that this concurrency is based on message passing, right? So these processes send themselves messages. Like the analogy I frequently mention is it's kind of similar to microservices. You have like the same idea there. You have independent programs. They are communicating through some form of messaging, like whether through HTTP requests or maybe through some third-party queue. Here you have like similar idea, except you use those lightweight processes, so you can run like hundreds of thousands or millions of them, or hundreds of millions. I think something like 100 million is a theoretical limit. And this messaging doesn't necessarily involve networking. As long as you're on the single machine, then there is no networking involved. But otherwise, it's like a similar principle. And yeah, I think I kind of covered. I don't know. Did you think I missed something?
Yeah, well, I think that's all. I just want to emphasize for the viewers that the message passing that happens when something crashes is exactly the same message passing that happens during normal operation, which is really cool. And also something that for me was very amazing when I first touched Erlang was in 2011 or something like that. It was that even though it's like not very popular industrially, but like in principle, you can basically create clusters of computers and join them together just with language, just with like standard library. Start passing messages between them. I wrote back in the day, just to get kind of my hands dirty with Erlang. I wrote like a system that sends notifications between phone, computer, like everything that was in my home lab. In Erlang, it was like distributing these notifications. I used to have notifications enabled back then. I didn't know better, but yeah. So it's really cool, and I think that is basically it. And
and it's somehow cool that basically everything revolves around concurrency, right? So concurrency is like the basis for building fault tolerance, for building scalable systems, like vertically scalable, so they can use all the CPU cores, and then you can scale on larger machine. And then it's also the basis for horizontal scaling, for distributed computing. So you basically use the same programming model. I mean, obviously the challenges are different when you're running on multiple machines, but still most of the code is kind of agnostic of the fact that you're actually using like one machine or X of them.
Yeah. You certainly can even, if we're talking about like in the industrial setting, you can certainly even like split kind of teams into people who are writing business logic versus people who are thinking about, okay, how do we actually deploy it in a scalable way that we can upscale and downscale. And that's really cool. So we can, I think, move on to like kind of discussing the state of Elixir right now. But to discuss the state of Elixir right now, we should actually talk about how did it come into existence? How did we go from Erlang and this amazing property that we're discussing right now to Elixir? Like, why do you need anything else if we already have these properties, right?
Yeah, so as far as I recall, I think that on very first Elixir Conf US, Jose gave a keynote kind of explaining some of those ideas. I'm going to try to summarize them as best as I can. I think like the gist of the story is that Erlang is terrific as a language, and I mean this whole model basically exists because of Erlang, and the runtime layer is particularly the source of the magic here. That being said, especially back then, so like we were talking about, I think Jose started writing Elixir in like 2011. I started using Erlang in 2010, so that's a little bit before that, and it has like these fantastic parts and then maybe some not fantastic parts. I would say that most notably the language was, and I would say still is, maybe too simple. That's kind of, many people think that Elixir is like simpler language because it looks more familiar in the syntax, but actually Erlang is simpler, much simpler in my opinion. But, simplicity also comes at the cost of expressiveness, right? Because then I found it hard in practice to kind of flush out some boilerplate and organize my code as much as I wanted to. I tried some tricks, but never really was happy with that. If you want to take this to a logical extreme, assembly is super simple, right? But you don't want to really write some complex code in assembly unless you really need to. So I would say that's one part of the story. The tooling was, especially back then, like substandard. You didn't really have like some default or blessed way to build your applications, and there was I don't think that there even was some sort of a package manager. So
I'm very sorry to interrupt, but like the first thing that I wrote some Erlang code, and the first thing that was really puzzling for me is how do I run it? It was very confusing. There is no main function. Like, what do I do?
And there were a couple of these third-party projects, but it wasn't like clear whether you should use like this or that, and different people argued for different things. I remember that I actually brought something on my own, which was backed by Ruby. It was like pretty unclear. So I think that Jose set out to Jose basically decided like, okay, this Erlang, this is some great stuff. This is fantastic stuff. Especially he had some experience trying to solve concurrency problems in Rails, if I remember correctly, with traditional models of locks and whatnot. So he figured like, okay, this is really the way to go, but I'm missing some things there. So, I'm going to try something which is maybe gives me, more expressiveness in the language and better tooling, and which is like more approachable for a developer, so to speak. Because I would say that's my personal view, but I think that like Erlang was kind of not super approachable. You sort of had to find your way and experiment a lot. It wasn't really clear about how you should do a bunch of different things. So yeah, that's how I would explain it, and that's what I think was the origin and the aim of Elixir, to be somehow more focused on developer productivity and assisting developers than Erlang back then. From that time, I feel that over time Erlang has taken some inspiration from Elixir, and of course, obviously, vice versa.
Yeah. So actually, it's maybe we can hop into the present for a second, and I'll ask you that question. So would you say that right now, when we have like purely Erlang projects, like for example, I had to write some Erlang, like, I don't know, last year, and I was using Rebar 3 for everything. How would you say how well integrated like Mix infrastructure is with Erlang right now? Did it like deprecate everything? How does it go right now? What do you say?
Yeah, to be honest, I have no clue. I recall like maybe 2 years ago, I read like people mentioned that it was a bit problematic compiling Elixir when when you have an Erlang project and then you want to compile some Elixir stuff. That there were some challenges, but I think there was some Rebar plugin anyway, and I'm not really sure what's the state of that. The other way around it definitely goes. So like you can pretty much integrate standard Erlang libraries, and you can write Erlang code, like have Erlang source files directly in your main project. So that's something that I'm not sure that everyone is aware of. I had an experience of when we were back at my former company, we were switching from Erlang to Elixir at some point, and we had like a pretty fairly complex project written in pure Erlang with some custom libraries, parse transformations and whatnot, something which is a bit off the beaten track. And it took me like maybe half a day to just write a Mix project which compiles this entire source tree, and the tests were passing and everything. So that was definitely possible. Yeah, and then I recall from my very first production, it was also Erlang production. As soon as I discovered Elixir, I just threw in a couple of things. I did some hacky stuff to make it work, but it was definitely workable. So I'm hoping that today the state is better, but I don't really do Erlang for like now 5 years or so, like plain Erlang. I just focused on Elixir.
Right. Actually, it's maybe a testament to the simplicity of the syntax, because after a big pause, when I had to really quickly, I was basically doing like binary editing for a capture the flag problem on a ITSec CTF. So like, yeah. By the way, we didn't touch on that binary pattern matching. How amazing is that? Like, I went through 3 hex editors that people are using, and they just couldn't give me the tools that 15-line program in Erlang did. And since I didn't really remember like how to do binary pattern matching in Elixir, I just took Erlang, and my fingers remembered like very quickly. So maybe it is easier in terms of syntax.
Well, yeah, Erlang is definitely. I think it's weird, but the first time you look at it, right? Unless you did some Prolog, but it feels strange, I would say. But once you get used to it, it's like very simple, very regular, no particular ambiguities, and I would expect that like the syntax tree or the grammar is definitely simpler than Elixir. That's my guess, but I think it's like a good guess.
Yeah. I mean, but Elixir is more complicated for a good reason. Like it supports such amazing macros, and like I like to use this as an example. The Unicode module in kernel, right? It's just beautiful. It takes some text files, and you don't have to maintain it at all. It just creates Elixir creates your compiler code by just taking like Unicode standard. It's wonderful.
Yeah, absolutely. And I mean, we have a bunch of different examples where it's just more expressive, so you can more elegantly do more complex stuff. which are possible, of course, in Erlang as well, but it requires more. And so you have like these examples of, say, Ecto, which is a sort of like an embedded SQL language or data mapping between databases. And so you can write these kind of SQL-like queries directly in the language, and they seem as if though they are a part of the language, but they're written with a macro. So really what the macro system does is it makes the language extensible, and it has been used by some prominent projects, and more recently, like I think in the last few days, the NX project was uncovered, which moves into the machine learning territory at some behind the scene JIT compiling and running on GPU and whatnot. And this was done without basically any intervention in the language. So I think like the language itself is mostly, if we take a look at it from 1.0 to this point, I just kind of reminded myself today, I was looking just through release notes. The language itself, if you talk about the syntax, there was just maybe one thing that was changed or added. It's mostly stable in the sense of the language. Mostly they add like standard library features or improved toolings, like there is tooling for some release added something for drawing or displaying cross references between modules. And then in another version, they maybe improve the output of X unit so you can better see the errors. So a lot of the stuff is done on the quality of life, but the language itself is like pretty stable since 1.0. So this is a testament, to, and the macro system actually makes that possible.
Yeah. So you mentioned some changes to Elixir releases. So if you had to like pick one of the most exciting feature of Elixir ecosystem post 1.0, what would you pick?
Oh, this one is really hard. Well, I would say that maybe the official support for OTP releases, that one was pretty big. And then the registry. So registry is something that I was personally saying like we should have the registry support. So for those who are not aware, like what registry means is, like I talked about, you have these processes, and very often you want to name those processes in a dynamic kind of way, and this is what registry is for. Typically those were done through some third-party projects, but then you always had to add those projects. And what Elixir does is it introduces this registry as a native part of the standard library. So you basically don't have to deal with that, and it's something that I use very, very frequently. The formatter, that's kind of an interesting thing. So I was personally against formatting because I think that I like the style formatting, right? The code formatting. So I was not a fan of those things because I think that like it kind of limits your creativity and how are you going to express yourself. But now that I have been working with it, I really think that it works wonders, and basically the good outweigh the bad stuff by far. So there are some occasional cases where I don't like what formatter does with my code, but then the good point that Jose made when he was introducing this is that like if your code looks bad after formatting, then you probably need to refactor something. Like maybe like the example I think he gave was like you have 10 parameters in a function, and then the formatted code looks bad, but you really don't want to have the function accepting 10 parameters. You should refactor to accepting some kind of structured data and things like that. So this is one which is kind of seems not particularly significant, but actually adds a pretty good quality of life.
Yeah, that's cool because, for example, again, in Haskell community, we very like to make like one thing 5 times and then publish it on Hackage. So, and the same goes for like code formatting standards. Like, I mean, to be completely honest with you, I think we have in our company a standard, but I'm not sure what it is, and I'm just using VS Code formatter, and I literally installed VS Code just so that I can collaborate with my on my pet projects with other people, and have a reasonable degree of assurance that I will not break patches, that I will not have noisy patches, basically. And what's funny is that immediately after I had to edit some of the Serokell's code, and I had extremely noisy patches. So that just saves a lot of time.
I think that's a pretty good point, that you basically, like you have such tooling that can enforce stuff automatically for you, and then you can actually focus on the real problems. Part of the reason I was opposing to formatters is because like it's, your code will not be significantly readable after it's formatted unless you're really writing terrible layouts. But the readability problem comes from like design, proper types, proper abstractions, and the formatter cannot handle this. But the thing that I missed is like without the formatter, then you end up arguing a lot about, should this be inline, should this be multiple lines and stuff like that, and you lose your energy on that. And once you have the tooling for this, then you just, goes out of the way. So for my current clients, very big things when I started working with them, I basically actually introduced a bunch of, these small tools like formatter. Then there is this Credo tool, which is like a linter. And so we use a bunch of this stuff to automatically enforce the guide, the style guide. So the style guide is basically like 2 pages. One of those pages, or 1.5, is explaining how to set up Credo and things like that. So these tools. So basically, it's just tool enforced. So this is pretty cool.
Right, and as far as I could tell, again, I'm not entirely sure, but it seems like it has pretty good integration with VS Code, for example, which apparently is something that, it has a nice Vim mode, so it's okay to use it if you're not against Microsoft. All right, and what about BEAM? What happened to it in the past 5 years? As far as I heard, there is just-in-time compilation right now, and it sounds pretty huge. What are your
just in time? You're just in time for the just-in-time compilation. I think it's officially going to land in 3 months, in May or something like that, in the next version. But it's basically there already to be explored. I think they were otherwise doing different kind of minor improvements from version to version. But yeah, I would say that like JIT is the big news. So from what I've read, I think that they mentioned something like from maybe 30% to more than 100% of speed up, depending on different cases they have tried out.
Yeah, their blog post says 30 to 130, but just for our viewers, maybe you will talk a little bit about what is just-in-time compilation and whatnot, like in 2 words.
That's a pretty difficult question, because as far as I remember from reading that blog, they actually don't do like the standard just-in-time compilation.
Right.
They actually they don't do like the tracing and stuff like that.
Yeah.
So they basically compile, but ultimately it boils down to the fact that they are compiling it natively, right, to the native code. That's the gist of it. So prior to that, the code before JIT, the code is, or without JIT, the code is interpreted constantly. So you basically compile your code down to some bytecode, and which is BEAM specific, and then you have the BEAM interpreter, just running through that, and JIT essentially takes it to the native level, so it can speed things up. Prior to JIT, or we still have this thing called high performance Erlang, which was kind of a mixed bag. Sometimes yielded good results, other times actually made things worse. And as far as
it's
I remember,
kind of like C Python or PyPy, like this is hype approach, as far as I understand.
Yeah, as far as I remember, then not all the things were possible with hype, and JIT JITting shouldn't actually drop any guarantees. Anyway, the long story short is like, why are we excited about it? Is because BEAM languages are historically not really known for their speed when it comes to processing. So they're not like super fast. Most of the time, really doesn't matter. So you still have like pretty fast operations, and with their support for concurrency and everything, they can give you this whole different dimension. Otherwise, when we talk about sequential program, if you like are able to do proper technical optimizations and algorithmical optimization, you can pretty much boil it down to the level where it doesn't matter. So like I never did like proper measurements, but my gut feeling is that BEAM language will be something like 10x or maybe even more than that, slower than say C. But if we're talking about like, is it going to be 1 microsecond on 0.1 microsecond? Really, most of the time, that's like completely irrelevant.
Yeah, but you have to have also prowess to like for example with Elixir script, right? It loads very slowly. Like it literally, like it just like loads the computational environment very slowly. And if you don't set up your release correctly, because like I was doing this benchmark actually like a couple of years ago for something, then you can have like very big performance penalty if you don't strip down your kind of release to only the things that you need.
Yeah, precisely. And depends on what you're measuring. But ultimately, when it comes to like sequential processing, when you have like some fast iteration, it's going to be much faster in C or even in Go or those kind of languages. So JIT should definitely brings us closer to those languages, to the point where I feel that still when you really care about squeezing every single ounce, every single like nanosecond, you will still have to do that critical path maybe someplace else. But for many cases, I feel that JIT should be just good enough. So, and that's it's always worth remembering that performance is just one part of the story. So it's not just about ultimate speed, but it's about like stable progress. I was explaining this. I gave this talk about 2 years ago, called Soul of Erlang and Elixir, where I explain some properties. So like for example, BEAM schedulers, they do like preemptive context switching, So what this means is like if you have one program which is stuck in a loop, like while true semicolon, just spinning around, it's not going to block anything else because BEAM frequently does this context switching. So the system progresses at a stable pace. In Go, for example, such program would actually block your scheduler. So if you have like, 5 schedulers and you have 5 of those Go routines, then you essentially end being completely paralyzed. Which will not happen in BEAM. So it's not just about speed, it's also about safety, and having like some reasonable scheduling resources distribution for everyone.
Yeah, it's actually interesting to also consider the fact that like there's this GRISP project, which is basically Erlang stripped down as much as possible to, first of all, be able to be ran as a single process, like real-time operating system. And second of all, just being able to run on hardware overall, and they have their own standard library, but what is very interesting is that they don't bring all the runtime, because you don't really need have like 2 cores on embedded, right? But what they bring is they bring kind of OTP patterns. So basically now when you are programming your like you can actually program like some controller for a motorbike that is controlling like injection of fuel or something with this. And actually what their argument is that by stripping that stuff down and just having OTP concepts, they make sure that failure will be kind of that what we talked about before. Even in like the sort of hardware systems, failure will be caught and failure will be handled, and no bikes will explode on track or something like that. So it's interesting how there are different people taking this notion like in different ways and still like kind of taking something out of Erlang infrastructure. Yeah, and there was this also very like sadly dead project, Erlang or something like that. Do you remember when they ran? Yeah, when they ran like Erlang on Zen. Yeah, that was also very interesting.
Yeah, that one was pretty cool. As far as I remember, they like basically rewrote their own runtime over Erlang.
Yeah.
For that, but it was pretty interesting idea. Yeah, but I mean, like Erlang has this idea. We often say that it's like an operating system for our code, because it's really what it is. Like you even have Erlang ships with its own internal top tool. Like you start top and then you see like what you see in standard Linux, for example, when you see like those processes and their usage sorted, I don't know, by reduction and whatnot. So it gives you OS-like features directly in the code, and so you can manipulate those features directly from the code, right? Which is pretty cool because there's less need to step outside and like to run a bunch of completely independent programs and then tie them together with systemd and whatnot, which complicates the story much more significantly. Here you have actually everything from within the single project. I just started project, everything is running, like background jobs are running, periodic jobs are running and whatnot. I can test that stuff very easily because everything is just in there in the same project, and I don't need to learn new things, because everything is expressed with standard Erlang or standard Elixir, whichever language you're using. So it actually requires much less of additional technical knowledge. It lowers the bar in a good way. So reasoning about this, implementing this is, in my view, much simpler than your standard microservices, which really just explode in terms of technical complexity.
Oh yeah, and actually, to an extent, I was during NixCon in 2015. I was talking to a person who was doing basically operations, like IT operations in one of the huger music hosting services. I wonder which one. And he was saying that basically at his work, they're using Nix to, for the first time in a while, be able to know what do they have running in terms of microservices and what will happen if they take some of them down. And I have a feeling if it was like 100% Erlang code base, then you just look and it will draw you like visually even what is going on with your clusters and whatnot.
Precisely, you can fire up this observer thing which ships with a standard Erlang. It just gives you a GUI. This gives you this nice tree, and you can like really see a nice visualization of what you have running. And I mean, yeah, this for me is the dream. Like I want to build as much of the stuff as I can as a monolith. So this is a single project. It's not a single binary, it's a folder structure, but there is the single artifact which you deploy, you start it, and everything is running from within that. And I want to have that as much as I can. And if for whatever reasons we can't have that, then it means that the tools are not developed enough, that we have some room for improvement. So we can reduce the need to run multiple OS processes side by side.
Yeah. Actually, for me as well, I have this philosophy that okay, sometimes we need clusters. Okay, sometimes we even need heterogeneous clusters where different servers have different roles. But okay, I can still kind of, at worst, kind of manage it from one umbrella project. At best, I can just manage it from the same project and just launch different code paths depending on what is the capability that the server is providing.
Precisely. This is what I advised to some other clients. That they came to me with this proposal about microservices, what they want to do, and I said like, okay, why don't you just put everything in a single project, not umbrella, regular project, and just set environment variable. What do you want to start? In development, everything starts by default, and now you have like development starting is super easy. Testing becomes easy, like these integration style tests when you want to verify how different different parts of this interact together. You can get this like reproducible on a local machine with practically zero infrastructural support. You don't need to run, I don't know, some kind of a Redis or etcd and whatnot. So it makes sense. Sure, you're shipping, I don't know, some megabytes more to every machine, but seriously, unless you're doing with embedded or some very restrained environment, this shouldn't be a problem.
Right. Let's talk about, well, since you're doing consultancy, you know way more about that, I think, than just being like a software developer going to a job. So maybe you know more about like demographics of Erlang and Elixir these days, and namely Elixir. Like, is that like 90% Phoenix crowd? Phoenix is like a web framework, which is actually really good. We should talk about it a little bit later. Or is it like 50-50? Is it people who are coming from Ruby? Is it Erlangers? How's it going right now?
Well, I mean, it's really hard for me to draw. I don't have such a large sample, yeah. But most people doing Elixir are doing it with Phoenix. Or, well, I'm not going to say most, but a lot of people doing Elixir do it with Phoenix. Typically, when someone approaches me, there is some sort of Phoenix kind of interface involved. I would say that my impression is that Elixir is more popular these days than Erlang. More recently, we had I think maybe 2-3 days ago, I've seen that Elixir actually came to the TOB index 50 lists. And I want to say, personally, I really don't care much about these shallow matrices, these shallow vanity indices. That being said, it's nice to actually see it as a sort of a validation that people are using Elixir more and more. And that's kind of my subjective impression also from, watching forums and other kind of knowledge exchange places. So yeah, definitely feels that Elixir is, getting some stable traction, not like explosive as, I don't know, Go or JavaScript, but, it feels that it's definitely growing steadily.
Would you say that when you're dealing with other people's code bases, would you say that people on average kind of understand the philosophy of underlying computational model, or would you say that there are problems? I'm asking because when I was just starting, it felt like Erlang felt very compact. So I wrote my first kind of high performance thing, like high throughput thing, in 2 weeks from when I first from I first looked at erlang.org, right? But then I showed it in IRC on the channel, and they said, okay, you can't do this. It will just break and you won't recover. You have to use found link and you have to use OTP. So then I went and read, and there was just no other way for me to express myself except for following best practices and kind of understanding, how scheduling works and everything. So do you think that it's a problem, or do you think it's okay?
This is definitely a problem. I think that this is the biggest problem. It's been a problem for me, and most of the time that I see it's kind of so I don't want to say it's hard because it's not hard, and I'm gonna, this is the hill I'm gonna die on. OTP and this concurrency is not hard, but it's something that we are basically not used to. There's nothing like it. I don't know anything like it. Maybe if you're coming from Scala and Akka, which took a lot of inspiration from Erlang/OTP, then maybe it will be familiar to you. But most of the time, those patterns are not familiar to you, and then you kind of use the previous knowledge and try to kind of work on top of that, and then you inevitably end up with anti-patterns, basically, maybe not properly taking care of, proper cleanup in a supervision tree or race conditions or stuff like that. So it's not hard, it's just something that you have to get used to. I guess the good news, though, is that OTP is very forgiving. So even when you do things wrong, it will not take your system down, as I have seen it myself many times. And otherwise, it's I find it pretty intuitive to think about in terms of this message passing as well as supervision hierarchy, which is basically just a top-down view of your process tree. You say, my system consists of, say, a backend and a front end, and backend consists of a database and some sort of a consumer and some periodic job, and front end consists of this endpoint which listens on the HTTP and that one which listens on the HTTP. So it's like a top-down breakdown of what your system consists of, and you just have to pay attention that whenever something stops, you want everything that is underneath it to stop. So those are kind of, it's not very hard, but people are definitely being confused. So this is something that as a community we have to work on.
Would you say that kind of more high-level frameworks and things like this contribute to this obscurity of underlying concepts, or would you say that it would be the same if Erlang was as popular as Elixir?
Oh, so yeah, that's definitely an aspect that I forgot to mention. This is a really, really good point. So the curious thing is that I think Elixir really makes things easier there. Well, it makes it easier because in the sense that you have stuff such as Phoenix and Ecto and other kind of these high to medium level frameworks/libraries. a lot of the time for like simpler scenarios, you don't even have to think about this. It's just taken care of for you, so in a good way. And so this is pretty cool. Like even for my main clients for very big things, somewhat surprisingly, I built like a recommended literature for new people coming to Elixir, and I didn't include my own book because my own book focuses on concurrency and OTP. And essentially, for the kind of systems they are building, this is not so much needed. Most of the time you can get by with like Phoenix, Ecto, and Absinthe, which is used for GraphQL. So occasionally there is some need for a little bit of concurrency, but not so much. So I didn't come and say like you should read my book. I actually come and said like you probably don't need to read my book unless you actually need to deal with concurrency. So in a sense, Elixir or its ecosystem hides away a lot of that stuff. Obviously, it's a double-edged sword because then you are not forced to learn it. And so once you need to deal with it, it's kind of, it feels alien for you. Yeah.
Interesting take. Yeah. And I think we can kind of talk a little bit about what are you working yourself right now, or where you work, or you were working last year. Like I've seen some exciting tweets about some kind of OTP-esque concepts that people might want to consider. So you might talk about that stuff a little bit before we start talking about the future of Elixir.
I have like three sort of main open source projects I'm kind of currently looking at, maybe 4. Yeah, I should actually take a look at my own GitHub repo. So I'm just going to briefly go through those. One of them is called Parent, and it basically explores somewhat different take on this hierarchy of processes. It's basically pretty similar to standard supervisors that we use, but it gives kind of more programmatic power to supervisors. So like the problem is, what we have supervisor, which is an abstraction that basically watches on other workers and restarts them, and otherwise stops them and starts them if needed. But you cannot really add some custom logic into that. And so parent is kind of like a lower level building block that actually lets you build custom parent processes. You can build supervisor and it ships with one out of the box, and otherwise you can build other kind of things. This is something that I needed in various different cases. So it also explores different kind of dependency management between processes. So yeah, I'm not going to go into all those details, but I think it's a kind of interesting take. And so far, as much as I've been using it, I'm kind of happy with it. Another project is called Site Encrypt, and this is basically Let's Encrypt certification. And in itself, I think it's important because it sort of showcases the style, the idea that I want to see more built in Erlang. And this is the fact that we can build more stuff directly in BEAM without needing anything external. So when we talk about the SSL certification, like if you're building it with some other language, typically what's advised is you install a third-party tool called CertBot or something. There's CertBot and there are other tools. And then this tool will obtain your certificate for you. And so now you have to run something else on the side. You also have to install Python for that and whatnot. So it complicates the story. And I figured that like since we're in BEAM, we don't really need all that, so we can run the certifier program directly as part of our application. And this is what Site Encrypt does. You add it as a library, fill in a couple of blanks, and you have basically within your project, you have this process running which will obtain your certification and integrate with your Phoenix endpoint automatically. So it just works out of the box. The cool thing is that it also ships with a development/test time server, mock server. So like when you start thinking locally, you're running your local Let's Encrypt, so to speak, and your program, your site self-registers locally as well as in tests. So you can actually test some stuff about that. And you don't need to run anything on the side, right? So this is pretty cool. You just add a library, fill in a couple of blanks, and you're good to go. Everything is running, no impedance mismatch or anything. So this is as a library, it's a small example, but it's an example of the stuff that I would like to see more. Push more stuff into, Elixir and Erlang. Yeah.
I have a very brief question about that. So yeah, normally the pattern is run certbot, run nginx, and then run your thing over plain HTTP, listening only to localhost and then reverse proxy, which comes with some issues, but in general, it's like, okay. So does it mean that with your approach, you also you also use like Cowboy TLS?
Yes.
Like,
yes.
Oh wow, that's so cool.
Yeah, so you can see it on my blog. My blog is basically just plain Elixir directly on the internet. So there is no Nginx or anything in between, and yeah, it uses Cowboys SSL, which you get through Phoenix. You just set some flag and that's it. And the site certifies itself. I would just push this to production. It's just been working. Occasionally, I remember like every few months or so, I'm just going to check, is my certificate still valid? And I just see it just is valid, and it simplifies the deployment story tremendously, right? So all of a sudden, you don't have to add like Nginx and certbot and whatnot. So everything is directly in there. The library also periodically, creates this tarball and puts it on some shared folder, which then goes, it's backed up and stuff like that. It's like so simplifies this story. It essentially brings the operations part back to the development. For me, this is truly a DevOps, if you will,
right?
Because and all of that is testable. So that's cool stuff.
Yeah, it's even more dev. Like for example, in Serokell, we were like fighting hard to instill proper DevOps methodology and infrastructure as code. But if your programming language lets you program your operating system, right, and your stuff runs in this operating system, then basically what you get is then your DevOps is also written in the same language, which is beautiful. I think I never even thought about it like in these categories.
And it simplifies the story, and it actually makes it more accessible to everyone. Like, say, everyone on the team knows Elixir, then they immediately know all the technical prerequisites to work on that part. Whereas if you have some proprietary YAML, most people are just going to ignore that. You always end up on a team, there is like a Circle CI specialist, a Travis specialist, specialist for this kind of YAML, that kind of YAML, and no one really wants to touch that, other than those people. And that kind of sucks, but if everything is expressed in like your regular language and you can reproduce it locally rather than I'm going to change some YAML, push it to that black box and see if that works. So if you can do this locally, you can code and you can see immediate feedback, then it's much easier and everyone is going to be more inclined to contribute to
We're trying to achieve similar things with Nix, but it's very difficult to get people excited about programming in Nix. Because I think it has this vibe of being a language to just define like a package, like something like your package build from Arch Linux thing, where it's really not. I don't know. Yeah, but we're trying to do this to do kind of the same. If you know Nix, then you will basically treat this infrastructure really as code, not as configuration. And I really think that what you described with playing with YAML configs is that it's like not real DevOps. Yeah,
this is to me horrible. It's very clumsy, very error prone, and I'm not really a fan of that. So this is kind of we can sort of tie this to the point you wanted to bring next, so to the future of Erlang. This is where I would like to see Erlang and Elixir take off in that kind of direction. They are already there in many ways. So like I frequently mention, you can really compare to other languages, especially scripting languages like say Ruby or Python or JavaScript. You can really simplify the deployment, reduce the amount of moving pieces. You don't necessarily need Redis, for example. You may use it, but you can get away without it. For periodic jobs, you can do something very lightweight directly in the Beam instead of reaching for cron or systemd or something like that. So this is where I'd like to see the story evolve even further. Like if you ask me, I would like to see a native database written in Elixir, like an SQL database. We already have a precedent of a thing called Mnesia, which is a key value database written in Erlang. So it's not something unheard of. It's a lot of effort, but it would be cool if you could actually start your database as a part of your entire system. You just have your supervision tree and I'm going to run this server and I'm going to run this database, which runs directly in there. I would like to see parts of Kubernetes provided as a library in Erlang or Elixir. And this is also not unheard of, right? If you remember React Core, for example, so it kind of had some of those. If you squint a lot, it's sort of similar, but basically the idea was there. You have like a bunch of computational resources, machines, and then this layer spreads the load across that. So this is something that could definitely be done on top of distributed Erlang. Obviously, it also takes a lot of effort, but it could simplify the story as well. So I would like to see stuff moving there. So just to wrap up with what you asked me, what I'm doing. Another thing that I've started this year is called CI. It's like continuous integration toolkit as Elixir library. So this one is inspired by the actual work I did for my previous company, where we built our own CI with Elixir. And this was by far the best CI I have ever worked on, because it involved zero YAML, and it was very expressive, and you could program it in Elixir as opposed to these ad hoc non-Turing complete languages. And so now I'm trying to build it in a our implementation was, of course, pretty ad hoc and everything, so it wasn't open sourceable. Now I'm trying to actually provide it as an open source thing. So it's already there on GitHub, very basic, but I have some ideas about this. So in general, as I said, I would like to see the whole community try to push towards this ecosystem where we can, do a bunch of stuff directly in Elixir or Erlang without needing to run multiple processes and needing to, use microservices style.
Yeah, it makes sense, and it's actually really interesting how I wrote a post last year, I think, about the history of Erlang and Elixir, and I quoted Jesper Louis Andersen, his memes about X is basically Y, right? So I wrote stuff like Erlang's message passing is basically AMQP, which is very in line. It's like ironic, right? But this is what you're saying, right? It's totally implementable within this this framework. Framework broadly speaking, obviously. All right, I think we should talk very, very, very briefly about the kind of cutting edge news with obviously NX, and talk a little bit about nerves. Just mention it, how, and the context I want to talk about it, and while we talk about the future of Elixir, is that there might be something like from Facebook or from a huge actor that will bring, let's say, proper static typing, maybe to just BEAM, to a language that compiles to BEAM just to modules. Maybe they will manage to type message passing as well, and that will, in my eyes, bring the best parts of Haskell, which is something that I think has a very big place in computer programming to make sure that your stuff is correct. Bring it to Erlang, and in my eyes, again, make Elixir basically obsolete. But what is beautiful about what Jose is doing is that I think they are like vendor unlocking themselves from this kind of, Phoenixy, crudy stuff by doing NX, and some other people are doing nerves for IoT. So you can very briefly talk about these things and your opinion about it.
Yeah, this definitely opens up some new possibilities. So NX, for those who are not familiar, it's just been announced like 2-3 days. I mean, Jose was teasing us about it for a long time on Twitter, but we didn't really know. You could kind of guess maybe what could it be. And I think that most of the guesses I've seen were like basically on target. It's like essentially pushing Elixir, opening this new direction into the machine learning territory, right? So NX, as far as I understand, is somewhat similar to NumPy, and basically has the ability to work with tensors and the library for tensors, which also has support for compiling down to or executing the stuff on GPU or /CPU. So basically for to get some decent performance out of it. It's a very interesting direction. I haven't been doing myself anything with machine learning, so I don't want to say anything wrong here, and therefore I'm not going to go any deeper. And besides, other than code and the podcast and the blog, we don't really know a lot, so we have to see.
Yeah, we will of course link. Yeah, we'll of course link everything. I just want to add real quick that I use term vendor unlocking for a reason, because as you said, yes, it runs on GPU and it targets a different backend rather than compiling down to BEAM, and
but it can compile down to BEAM as well, right? So
of course, it runs on CPU and it runs on GPUs as well, and it has this different compiler backend, which is a testament to like all these people, among people who are asking like, okay, is Elixir production ready, whatever it means. There were also people who were asking all the time, okay, well, why with this weird syntax? I don't like Ruby, it's hipster or something. I don't really remember the arguments, right? But like it's a testament to how powerful Elixir compiler is, because basically what they did over the course of a couple of months, they wrote basically a fusing mechanism to just like they have in streams, Elixir streams, a library or whatever subset of standard library. I'm not sure where it lives. Basically, they say it's kind of for Haskell crowd. It's kind of like we have by Gabriel Gonzalez the generalization of fold, when you kind of write your folds and then you run them once and get the result, and then the library and the compiler fuse the computations into one execution plan, right? So they basically wrote this fusing logic to make sure that we don't copy numerical computations, which is cool. But then they not only did that, they also extended the language in a way, right, to support regular fused computations on BEAM, which is like kind of regular execution mode, and they added another backend to run Elixir on in the span of 2-3 months. Like this is
and this is all done without changing anything in the Elixir itself, right? So
yeah.
I think there's going to, from what I understand, there's going to be like some very minor change in the next version, but it already runs on the current version, so there was no special support needed in the language itself. And this is a testament to what we talked about with macros and everything, how actually extensible the language is, and which therefore it makes sense that it's stable. I think this was one of the original Jose's goal, to make the language extensible such that he doesn't have to spend too much time just pushing it forward and forward.
Yeah.
So this is pretty cool.
Yeah, and it also again, to Haskell crowd, it would remove the need for committee in a way, right? Okay, you want to have dependent Haskell, you want to have like dependent Elixir, whatever that means with success typings. Sure, just extend it, import it as a library, like as an overlay to your compiler, and the code is maintainable, readable, and written in Elixir, on top of things, right? It's very very nice.
Yes, so that's pretty cool. And then you mentioned nerves. I gotta be honest, I didn't really follow the development of nerves, but it has been around for like, I don't know, 5-6 years or something like that since it was first introduced. The general idea, from what I understand, is to be able to run BEAM code, so Erlang or Elixir written code on smaller embedded devices, if you will, like Raspberry Pi, for example, right? And why would you want to do that? Is also to get better fault tolerance and general resilience, right? Availability, because many times in those smaller devices, you also want to run a software system. It's not like a powerful web server that, I don't know, handles thousands of requests per second, but it is still a piece of software that runs and maybe, I don't know, monitors your smart home or does whatever else. And you want it to run constantly, and you don't really want it to fail completely. And so, and especially because, this stuff can be deployed, reside somewhere remotely, it's hard to access and whatnot. So you actually have a lot of, you have to pay attention to make this thing stable. And therefore it makes sense to consider using BEAM languages for those kind of things. So Nerves is basically a platform that, from what I understand, gives you the full solution to that, including deployment at some helper libraries and whatnot. So you can run your...
Yeah, as far as I understand, they also have some sort of dashboards and whatnot. Yeah, but this is it's important about when we're thinking about nerves. It's important to understand that it's like very natural, also even in terms of like people were thinking about using Erlang in IoT at the moment when IoT became a thing. You know, like we have to always remember that the past of Erlang is programming phone switches. Yeah, so basically it was IoT because before it was too cool. And I know for sure, I don't know the projects. I don't know if they are open sourced, but I know for sure that there is also a drive to put Erlang on like hives of to deploy gossip networks of sensors, for example, so that the information from like remote sensors could propagate to command and control without having a direct connectivity and whatnot. So yeah, I think that I also think that like IoT is very like natural venue for Erlang to Erlang languages, Elixir, and so on to be deployed on. Yeah, so I think that the future is bright. I think that I'm really looking forward to what the community, maybe smaller community, a broader community, will do with typed Erlang versions. Yeah, you mentioned that language. How was it called? Like it starts with G or something. Yeah, Gleam.
Yeah. So there is Gleam and there is Caramel. I think that those are like two ongoing initiatives. There are a bunch of more that were sort of going on and then at some point maybe stopped. The Gleam is, as far as I know, in continuous development, and I recently learned of Caramel, which is also something ML flavored. So yeah, definitely, I think it would be great to get a statically typed language on BEAM. So I have spent a lot of years working with both static and dynamic typing, and I'm now at this point pretty much convinced that static is better for anything production wise. So it's saying a lot that I'm using exclusively Elixir, which is dynamically typed, because I think that these other advantages are really also very important. But I would like to see static typing at least. I'm not sure if I would completely go back to that, but for some like critical stuff, more complex stuff, like say you're writing a compiler or something, these are the pieces that I would actually definitely want to have proper static support, so I can actually reason about it properly. So yeah, I hope that the Gleam or Caramel, and then there is actually something which I think WhatsApp is developing. They promised they will release something in November, but that didn't happen. So but hopefully it will happen at some point. They're working also on some of typed Erlang, whatever that actually means.
Yeah.
So we're gonna see, But I'm really think that this is an important piece that we would have to get on BEAM to truly further propel the adoption.
I think a push from a huge company is really required because, like even when I started, I was reading this write-ups about, okay, here's the proposal to make Erlang typed, and then I have this phrase that, okay, we will have typed Erlang in 5 years, just when we will have a general AI in 5 years. It's always in 5 years for 10 years already.
And Linux on desktop, right?
Oh yeah, of course. We actually have a question to finish our conversation with. And the question says, with this approach of GPU things that NX has taken, do you think Elixir would be able to compete against Scala capabilities for processing big data?
Well, that is hard for me to answer. From what I understand, this is now currently mostly focused on machine learning stuff. So I guess processing big data would involve that as well. So yeah, I guess now that you ask about it and I think about it, it makes sense, right? So this is something where it could happen. I think that really the big question is maturity. So what is going to be supported by NX? Clearly, it's like a couple of years behind than anything else. So there's some ground to be
at least a couple of years, yeah.
Yeah,
and I would say that as far as machine learning versus everything else is concerned, I think that our first goal with NX, or implementers' first goal with NX, is to just provide sufficient set of primitives and algorithms that are rooted in numerical analysis and in statistics to be able to then be used to create more complex systems. And as far as big data, processing big data is concerned, I think that we have to always keep in mind that our big data normally, like, it's not always that we can just say, okay, we will process big data like as like a data pool of texts or something, and then load the GPU with some text processing things or some indexers. These things are not always machine learning based, and they're not always kind of boiled down to kind of stuff that TensorFlow is doing, right? So for me, it's more the question: okay, how can you actually transform your data into something with what you can work? And I think that, again, I have no idea about what Scala is doing, but I assume that Scala has tools to actually pull the signal, so to speak, from your data pools and from your big data. And I think that the Elixir, as far as I can see, I wouldn't be very optimistic that we will have like kind of full stack support for analysis of big data.
But I mean, it's at least setting the proper foundation, and so it depends on how much push will it receive. But from what I can tell, there is a lot of excitement there. So hopefully, we will get to the point where we can have some approximation, at least, of what other communities have. And something is always better than nothing, right? And more of that thing is better, especially much better, because there's less incentive for you to step outside of Elixir and reach for other languages then, right?
Yeah. Actually, to close this on a positive note, I now thought about it a little bit, and I realized that, okay, like things that in other languages, like in Haskell, we had conduit, and in Scala, I think similar things, which actually address this issue of like syncing the data from a data pool in a concurrent way down to like some distilled data set, and we can kind of reason about, or like do some ML or do statistical analysis on. We actually have this in Erlang kind of for free, right? So I kind of revert my answer completely. I think that if we will have an X, then just Elixir capabilities will be enough to actually do this whole thing. Just because
it's pretty hard to answer. It's a vague question. What does it mean to handle big data? It can be handled in a bunch of different ways. Like so when it comes to, of course, some sort of modeling and learning, obviously, as soon as you can do something on GPU, then you have much better capabilities. But other than that, what you mentioned, ingesting the data in a concurrent way and then splitting it and slicing it differently, this is definitely possible already without NX, and this is where BEAM languages actually excel.
I actually have one more question. Let's answer it as well. The question is, how do you see Elixir taking place for big companies' backends? Like, I guess, what's the place of Elixir in big companies' backends? And what's stopping its adoption if Phoenix is mature enough? So why? Yeah, I think I'll start answering, and Saša might add something to it. So like Elixir, we don't see Facebook internal or WhatsApp internal code bases, but my guess would be that they are using Elixir. I don't know for sure. No one knows for sure except for people who are working there. But like, they are using Erlang, and there is very little reason to not use Elixir over past several years if you're using Erlang already. And as Saša mentioned, interoperability is so high that, when we're talking about proprietary code bases, we can safely say that if a company is using Erlang, most likely they're also using Elixir. And we have huge companies using Erlang. And maybe Saša knows some huge companies that are using Elixir specifically, and they're vocal about it. But I would say that it actually was how many people learned about Erlang in the first place in like 2008, 2009, 2010, when Facebook did their first rewrite of Messenger to Erlang. And what's stopping this adoption since Phoenix is mature enough? Well, in my opinion, Erlang and Elixir are so much more than just Phoenix. And I think when I was preparing for today's interview with Saša, I was thinking about Live View, which is their recent feature by Phoenix framework, which allows people to not write JavaScript, but to have this kind of functional reactive programming inspired approach to do website like front-end re-renderings. And I have a feeling when I was thinking, okay, why would I use it? Well, if I have like kind of government customer or something like this, or I'm not making like user-facing applications and I want to keep everything Elixir, maybe I'm like some sort of startup that does a web only, then okay, I will use Live View. And the same kind of goes to, but otherwise I will not, because if I want to have consumer-facing application, of course, I will have to think about mobile, about all the horrible reality of writing applications for the end user. And just like this is kind of, and I still can use Elixir for backend, right? And just the same way in the whole range of problem domains of writing complex systems, Phoenix is not like 100% of what Elixir brings to the table. So in my opinion, it's very hard to answer the second part of your question about, okay, what's stopping this adoption since Phoenix is mature, just because Facebook or anyone else is not using these languages to do web. They are actually using these languages to build complex, resilient systems. If Saša has something to add.
I'm not sure that I understood the question. So can you just repeat what's the problem?
The question is, how do you see Elixir taking place for big companies' backend? So I guess that the question is like, where does Elixir fit in big companies' backends?
Okay, yeah. That's a difficult one. I don't really see it happen because typically companies are inert that way, and if they have something that is working, why should they really switch to something else, right? So what possibly can happen, and this really depends on the company's culture, is some pieces might be implemented, some new tools on the side, and I think that there are such scenarios already, but I can't think of something off the top of my head because my memory is pretty bad, so I purged my brain. But Elixir, on the Elixir side, there are some use cases of different companies, and as far as I remember, there were like some that were actually using Elixir like for different kind of tools, and there are of course then companies which are all in Elixir. Of the big ones, I don't know, the only one that I can think of at this moment is Bleacher Report, so that's one of the bigger that has been using. And then of course WhatsApp obviously uses Erlang. I don't know if they do any Elixir, but definitely Erlang is there. So yeah, to answer that point, in general, I think it's kind of I personally think it's going to be hard to just not likely to see that a big company that already has established infrastructure will go to Elixir, just because, right? So I don't see that happen. Obviously, if a company grows organically, then that could happen if it started originally with Elixir. Other than that, I don't see Phoenix as any sort of a problem to that. Phoenix is pretty mature. I think it's pretty stable, and I would recommend using it if you have to do something web-facing. Pretty convenient and also very flexible. So yeah, it's basically based on Cowboy that has been used around, has been around for like 10 years or so. So
yeah, and what also is great about Phoenix is that you don't have that Phoenix is not just one thing, right? You can just use subset of Phoenix like plugs, and this is for
precisely
what I'm doing, right? Because I don't have time to learn a framework, but I have time to learn like kind of approach to like request processing. So I just use the stuff I understand from it, right?
It's very modular, so really you can pick whatever you want, and like even though it proposes some conventions, you can even take different kind of paths, which is what we did very big things. We make some changes to that, the way we figure it suits us. So it's very actually unopinionated, I would say.
Yeah. Well, I guess that will be it. Thank you very much, Sasha, for taking your time, taking so much of your time, actually, over an hour. Yeah, I hope to see you in real life soon, hopefully.
Yeah. Thank you, Jonn, for inviting me. And this was fun, and I wasn't even aware that so much time has passed. So anyway, hope that it was interesting for others. And personally, of course, I'm looking forward to the day when the COVID is going to be the thing of the past, and we can see each other in real life.
Right. Thank you, and thank you to everyone who was watching.
Bye bye.
Bye bye.